Today we're going to talk about finding cube roots. In the previous section we did square roots, where we had a number times itself 2 times. Now we're looking at cube roots. So we start out that last lesson asking about what number multiplied by itself equaled 25. This one, we want to know what number multiplied by itself and then again by itself equals 27. It's a little bit more tricky to figure out cube roots because obviously you're now putting the same factor 3 times together versus the square roots, which is just 2 of the same factor. But if you think through this, 27, if I do 3 times 3 times 3, I get 27. The first 3 times 3 is 9, times another 3 would be 27. So 3 times itself, and again times itself, that's where the 27 comes in. Okay? This number is called a cube root because just like with the square root, it's the factor that multiplies over and over again. With the square root, it was times 2 of them. When it's a cube root, it is now times 3 of them. So, just like in the cube roots, we have things called the perfect cubes. These numbers jump a lot quicker than the perfect squares, so I'm just going to write a few of them. So 1 is a perfect cube because 1 times 1 times 1 is 1. Then we jump to 8 because 2 times 2 is 4 times 2 is 8. Then we would go to that 27, so you can already see how much faster we're jumping. 4 times 4 times 4, 64. 5 times 5 times 5 is 125. 6 times 6 is 36. Times another 6 is 216. And that's good enough. These numbers jump pretty quickly. And again, if we're not really sure, we can always use a calculator. But these numbers would be perfect cubes up to the 200 because they would have an integer answer when you took the cube root. There is no decimals or fractions. So this symbol, which looks similar to the square root, except that we have this little 3 kind of tucked in there. That is telling us that we need to find the cube root. And what it basically is telling me is that I need to find some number times itself 3 times. So that little 3 in there doesn't say multiply it by 3, doesn't say do anything with the 3. It's telling me that I need 3 of the same factor to deal with this symbol. We don't see it on the square root. There's no 2 in there just because that symbol is considered the square root symbol. This one and any others that ask for different roots, which you'll learn more about in algebra, have the number tucked inside the radical sign. So let's look at a few examples. So finding each cube root. And I want you to pay attention to a couple of these answers. So the first one says, what is the cube root of 8? So if I think about that, this little cube root means I need 3 of the same thing. So I need to find some number times itself 3 times. 2 times 2 is 4, times 2 is 8. So there's my answer. Looking at the next one, the cube root of negative 27. Now, when we did square roots, we couldn't have a negative underneath because there's no such thing as a positive times a positive to create a negative, or a negative times a negative to create a negative. But in the cube roots, because it's an odd number of factors, can't I still get a few things multiplied together to become negative? So 27 we just mentioned was a perfect cube, so I can take that number 3 out. Now, 3 times 3 is 9, times 3 is 27. But negative 3 times negative 3 is 9, times negative 3 jumps it back to being negative, which is going to be the answer for this. So we can do the cube root of a negative number, and then the answer will become negative. So the sign's not out in front on this one. It's going to be, in this case, underneath. So this one won't have the plus or minus out in front of the radical sign like the square roots did. The number underneath is going to be telling you if the answer is positive or negative, and it can't be both. Okay? for letter C. So the same idea that we did, I see two perfect cubes. I see the cube root of 1 and the cube root of 64, and that's going to help me find the cube root of 1/64. The cube root of 1, 1 times 1 times 1. The cube root of 64, 4 times 4 is 16, times 4 is 64. So 1/4 times 1/4 times 1/4 is 1/64. So here we have a few more examples. So again, we are still using our regular order of operations. So GEMDAS tells us the order to go. Just like with the square roots, the E exponents applies here for the cube roots. They are an exponent. And so when I look at this first one, it says to evaluate the expression, which means I need to come up with the answer. So the first thing I need to do is focus on what is the cube root of negative 216. So negative 216. 216 is a perfect cube, and that becomes a 6, and we know that that's a negative. Then I can bring down the 2. And when I then say 2 times negative 6, I get a negative 12. On the next one. So if I was to focus the cube root of 125, well, 5 times 5 is 25, times another 5 is 125. So the first thing would be to take care of that square cube root underneath. Then I can do the 5 to the third root, or cube root, and that's 5 times 5 times 5, which is 125. Now, just like we saw in the last section with square roots, when I have something that I take the cube root and then I cube it, notice that this radicand under here, this 125, is my answer. So we mentioned in the previous square root chapter, a section, that the square and square root undo each other. And that's the same thing here. The cube and the cube root are inverse operations. They undo each other. I want you just to pause the video, try a few of these across the bottom here, and when you think you have the answers, you can hit play again and it'll pop right up, and I'll just kind of touch on a few of these. So give these a shot, pause the video for a moment. So how'd you do? So here's just going through a few of these real quickly. So if I see the cube root of 1, just thinking about this out loud, that means I need 3 of the same factor. 1 times 1 is 1 times 1. The answer is 1. Once I have 3 of the same factor, that number can come out. Same thing here. So 343 is a little bit higher than we said, but if you look at 7, 7 times 7 is 49. 49 times 7, there's going to be the 343, which means 7 can come out and be the answer. This one, I did just one quick jump because I was thinking ahead to what I know. 27 is a perfect square. I'm sorry, perfect cube, so it wasn't 1,000. 3 times 3 times 3 is 27, so there's your 3's. 1,000, 10 times 10 is 100, times another 10 is 1,000, so 10 is that one. And we know that it has to be negative because a negative times a negative times a negative gets me back to this negative that we started out on. Order of operations here. First one would say the cube root of 8 is 2. Then we would take care of this multiplication before we did subtraction to get the 8. Then we can subtract to get the 10. And then over here, notice how I just jumped right to this. I'm not going to waste time saying that this is negative 4 and then doing the cube. We know that these two operations undo each other to get right to the negative 64, and then I add 43 to get negative 21. So going to some examples of solving some equations now, same idea. We still are using our opposite order of operations. So while I'm doing that, this first one, to undo cube, I'm taking the cube root of both sides to get x all by itself. So when I take the cube root, x cubed becomes x, and then the cube root of 216, 6 times 6, 36, times 6 is 216. On the second one, again, I have to think about which one do I do first. I know I'm going to divide negative 1/4 to both sides. I know I'm going to take the cube root to both sides, but which one do I do first? Think about your operations in reverse. So because of that, I'm actually going to do my division first and divide by negative 1/4, which hopefully doesn't cause too much of a concern. Dividing negative 1/4 by negative 1/4 causes them to cancel. And remember, when I divide by a fraction, negative 1/4, so I have 2 divided by negative 1/4, that turns into 2 times, and I flip over my 1/4 to make it 2 times negative 4, which is negative 8. It's not as difficult as it might look if you remember back to dividing fractions. So this is now still not just n, so I still have to take the cube root. But when I take the cube root, negative 8, that's a perfect cube. Negative 2 times negative 2 is 4, times 1 more negative 2 is negative 8. And lastly, we want to look at this baseball display case, which is made out of plastic. How many square inches of plastic are used to make the case? Okay, so we got a bunch of things going on in this one. So first, square inches to make the plastic. That's telling us that we're going to be looking for surface area. That's not looking at how much is an inside. That's how much is making the shell of the case. But we do have some information about the volume. So down here we are told these are the side dimensions, and these are S's, and we're told the volume is 125. So we have some place to start there. So what I'm going to first do is I'm going to look at the volume formula to find out, well, how much is each of these sides worth? Then we'll go to step 2. So volume. The volume formula is S cubed. We have 3 S's, S times S times S, length times width times height. The volume of a cube is S cubed. So we know the volume is 125. So the question is, how do I get to S? Well, we just said that the inverse of cubing is to take the cube root. And what's the cube root of 125? 5 times 5 times 5 will get me to that 125. But that's not just the answer. We got to make sure we don't think that. The answer there is, so 5 inches is this each side. Now I need to use the surface area formula, which we can see in step 2. The surface area, because each side is exactly the same and there are 6 faces to a cube, is going to now be S squared, because to find the area of the flat surface, it's just S times S. So I'm just going to plug in what I have. We have 6 faces. We know that each of the sides are 5, and if I multiply length times width, I'm going to get the area of each face. That'll help me get one face multiplied by 6 to get the whole surface area. So the surface area is going to be 6 times 25, and then 6 times 25 is 150 square inches, and that is how much plastic we need to make the cube for the baseball, which unfortunately right now cannot be played, but hopefully we'll be back to that as soon as possible. Hope this makes some sense. Hopefully it builds off of what you learned from the square roots the other day. And if you have any kind of questions or concerns, please let me know, and we can certainly help you through it.